Welcome back, everyone. In this lecture, we'll begin learning about NumPy arrays. Let's jump over to Jupyter and show you how it's done. Okay, here I am in the Jupyter notebook. To actually begin using NumPy, the first thing we have to do is import it. And we can say import NumPy as NP and then Shift Enter to run that cell. If you get an error here saying NumPy isn't recognized as an installed library, make sure you've activated our environment as mentioned in the course environment setup lecture. Okay, so let's talk about different ways to create NumPy arrays. One way to create a NumPy array is from an existing object, such as a list. So in Python, you have lists that are built in with brackets. So I can say my list and have it be 1, 2, 3. And if I check the type of this object, my list, it's a list type. If I want to transform this list into an array, I can say np.array and then pass in that my list object, and it will transform it into an array. Keep in mind that it doesn't permanently affect this. So if I say type my list, it's still a list. If I actually want the array, I need to say something like array is equal to np array my list. Then I can have this array object, ARR variable, that is a NumPy array. Now, what's more useful than just translating a single list from a built-in Python list to a NumPy array is to transform a nested list into a NumPy array, which is then actually called a matrix. So we can go ahead and check this out. I'm going to say my list is going to be a nested list. So notice I have 1, 2, 3 as the first item. Then I'll say comma, another list inside as 4, 5, 6. I'll say comma again, and then I have 7, 8, 9. So here I have my list. It's a nested list. And notice what happens when I'm actually going to cast this as a NumPy array. We'll say np array, and now Jupyter is actually displaying this as a two-dimensional matrix. And you can check how many dimensions it has based off the number of brackets that are shown at the very beginning or at the very end. So this is now two-dimensional because we have an x-axis and the y-axis, essentially two-dimensional matrix. And what's really cool is then there are built-in methods and properties for this array. So if I were to call this my matrix and then actually run that to define it, then I can say my matrix dot and then hit tab. And you'll notice that there's a ton of different methods and attributes that I can call off of this now NumPy array. And one of the really useful ones is shape, and it will return back the actual shape of this array, which is 3 by 3. Keep in mind, if you're getting an error when you're trying to look at these list of attributes and methods, it's probably because you haven't defined the cell that actually defines the actual array. So what I mean by that is if I say my new matrix is equal to np array and then pass in my list, and if in the same cell I'm trying to do the following, my new matrix dot, and if I'm hitting tab, nothing's going to show up. It's because I actually need to run this first in order for Jupyter to know what my new matrix is. So we have to essentially run this as its own cell and then hit tab, and then you'll see the options. And that's true for anything, not just NumPy. You have to make sure the object has been defined in Python in order for Jupyter to actually show you that list of attributes and methods. Okay, so that's one way to convert an existing Python list into a NumPy array. However, there's lots of really useful built-in methods for really common arrays, and we're going to be using these throughout the course. So we're going to talk about arrange, how to create arrays of zeros and ones, how to create linearly spaced arrays, and then how to create arrays of random numbers. So first, let's talk about the built-in methods. And one of the really useful ones is np.arrange. And the way arrange works, you can do Shift Tab here and it'll give you the information. It's very much like Python's built-in range, where you have a start, a stop, and a step size. So we can start at index 0 and then go all the way up to, but not including the stop index, so 0, 10. So no, this starts at 0 and then goes all the way up to, but not including 10. So the start is inclusive, the end is exclusive, and we have 0 up to 9. And then we can add an additional step size parameter. So by default, the step size is 1. It just goes up by 1 integer. But if we have 2 as the step size parameter, then we go up by 2. So 0, 2, 4, 6, 8, all the way up to, but not including the end here. So if I actually wanted to see a 10, I would just make this end 11, and there I see the 10. Okay, so that's how you can use arrange, essentially the same thing as Python's built-in range. We can also have zeros and ones. So I can say NP zeros, and then if I pass in just one number, such as 5, it gives me back an array of 5 zeros. And note that there's a dot here after the 0, indicating that it's a floating point number. So if we check out 0.0, the type of this is a float. It's not an integer. And it's the same thing if you just say 0 point, that's also a float. So that's essentially what this means, that these are floating point numbers. Later on, we'll have a more in-depth discussion of why NumPy often transforms things to floating point numbers inside of its operations. But for right now, just keep in mind that a lot of times you'll see floating point numbers when working with NumPy. So we have zeros here. If you just pass in a single number, it gives you back this one-dimensional array of a bunch of zeros, essentially 5 zeros if you ask for 5. But you can also pass in a tuple. So notice another pair of parentheses here with a distinct shape. So maybe I want 4 by 10 zeros. And so when you run that, you'll have 4 rows. So notice 4 counts for rows, and 10 is the number of columns. So here I have 4 by 10 zeros. And it's the same thing if you do np.ones. So as you may have guessed, this is essentially the same operation, but now we can ask for ones. So maybe I want 5 by 5 ones. And there you go. And what's really nice about this is NumPy allows you to perform operations that are broadcasted to every single number on the array. Meaning, if I take my ones and I add 4, what's going to be really cool is NumPy is going to automatically add the number 4 to each of those ones. And this is something you cannot do with a normal Python list, which is why people use NumPy in the first place. So as you can imagine, if we have NumPy ones and we say 4, that gives us 4 ones. And then what I can do is I can even multiply this by 100, and then I have 4 100s. So it takes every element inside this array and performs this operation on it. If I try to do the same thing with a normal Python list, so here I have 4 ones, however it's a Python list, no longer an array, and if I tried to multiply it by 100, I would end up getting 100 of these lists. It's not actually performing the operation. And if I try to do an addition, say something like plus 10, then that's just going to give me an error. It's going to say I can't concatenate a list to an integer because they're 2 different data types. NumPy has no problem with that. You can add, multiply, you can even divide. So I can say divided by 100, and then we get 0.01. You can broadcast these operations across every element in the NumPy array. That's one of the main use cases for NumPy, and it's something we're going to be doing often when dealing with time series data. So keep that in mind. Okay, so we have a little bit of motivation about why we'd be using NumPy. Let's go ahead and continue with a couple of more ways of creating NumPy arrays. We have the ability to create linearly spaced arrays, and that returns evenly spaced numbers over a specified interval. And it's a little different than the arrange we just saw. So what we do is we say np linspace, and then we say a start and a stop, and then how many items we want in between the start and the stop that are evenly spaced. So if I say 3, then there's 3 numbers that are evenly spaced between 0 and 10. It goes 0, 5, and 10. Or I could ask for a lot more. I could say give me 20 numbers evenly spaced between 0 and 10. And then it's going to give me these 20 numbers that are evenly spaced, starting at 0, going all the way up to and including 10. So again, it's returning evenly spaced numbers over a specified interval with a start, a stop, and then the actual amount of numbers you want. So here, there's 20 numbers. And you can check this, you can confirm this just by checking the length. There's 20 numbers there. So again, notice the difference between np linspace and then np arrange. Arrange, if we look back, it's just integers from a start, a stop, and then a step size. np linspace is an inclusive start, an inclusive stop, and then we get to ask how many numbers we want. So I can ask for 11 numbers here, and it'll go 0, 1, 2, 3, or I can ask for 100 numbers, and it'll give me 100 numbers evenly spaced from 0 up to that stopping point. All right, so that's linearly spaced, and then we won't actually use this throughout the course, but there is a way to quickly create an identity matrix, and that's NPI. And here you just pass in a single number, and it'll give you a 5 by 5 identity matrix. An identity matrix is just a matrix that has ones across the diagonal like this, where everything else is 0. So we don't really use this in the course, but in case you are interested in linear algebra, keep in mind that capability is there for you. Okay, now sometimes when you're trying to model data, it's really nice to just be able to quickly create some random data for you to play around with. And one way you can do this is using the random library that's built into NumPy. So coming up next, we're going to learn about this random NumPy library, and then we'll also talk about array attributes and methods, such as reshaping, getting the max, min, and getting the index of the max and min items in an array. So we're going to continue this in a part 2 of this first introduction to NumPy arrays. I'll see you in the part 2.